Some creatures seem to have no feet, and yet they're able to move around. Others have only one foot, and some have 2 feet in unexpected locations. How do creatures move if they don't walk upright or on all fours? This amoeba moves by shifting the living substance inside it. The body of this one-celled organism is a soft bag of jelly-like fluid called cytoplasm, surrounded by a cell membrane. Amoeba movement takes place this way. The cytoplasm constantly pushes out bulges in the soft cell membrane. These bulges are called pseudopods, which means false feet. When one pseudopod outgrows the others, the amoeba moves in the direction of that pseudopod. The amoeba pours some of itself forward into the foot, moving by shifting the material inside its body. Unlike amoebas that have no definite shape, one-celled diatoms have hard shells that give them rigid shapes. But like amoebas, they also use flowing cytoplasm to move themselves. By alternating the direction of flow of cytoplasm in a narrow groove in its shell, a diatom can move backward or forward without turning around. That's not the way rotifers move. There seem to be tiny spinning wheels at the front end of this simple but many-celled animal. That is the part that moves a rotifer, but it's not a wheel. Nothing turns. What we're really seeing is the coordinated movement of tiny hairs called cilia. The cilia move the rotifers along. Paddling cilia and shifting cytoplasm. Both forms of movement make sense for simple organisms that live in water. More complex creatures depend on the lengthening and contracting of muscles for movement. This is a larva, the immature form of a tiny insect. The changes in its muscles produce waves that move forward from the rear of its body. Each body segment is supported by bristles. As part of the body stretches forward, bristles hold other parts to the surface and keep them from sliding back. Like the body of the insect larva, the earthworm's body is segmented. These segments contain 2 sets of muscles. Some ring the body and make segments long and thin when they contract. The other muscles run lengthwise and make the worm's body short and stubby when they contract. The coordinated expansion and contraction of these muscles moves the earthworm forward along the ground and into it. Underground, the earthworm's changing body shape allows it to press against the walls of its tunnel. On its body are tiny bristles called setae. They extend to give the earthworm a better grip on the tunnel walls, then pull in and let its body slide smoothly along. Expanding and contracting in this way, the earthworm moves slowly through the ground. A flatworm, a planarian, moves in a different way. The flat bottom of the planarian's body has a thin layer of muscle. That layer can be thought of as the planarian's foot. It secretes a coating of slime that smooths the way as the animal slides along over a surface. Locomotion is mainly produced by thousands of tiny cilia attached to the planarian's foot. Working together in groups, these cilia push the planarian forward through the slime like a 1,000-paddled rowboat. Another animal whose single foot moves it along a trail of slime is the snail. The slime allows it to glide over irregular surfaces, but it has no cilia. The snail's head is attached directly to its foot. Most of its internal organs are up above, inside the shell. The snail's foot produces that layer of slime that helps it slide along. Muscles in the snail's foot contract in waves. Looking up at a snail crawling over a transparent surface, you can see that the waves march in parallel along the length of the foot. These waves slowly pull the snail forward. Of course, some places a snail might crawl are not as smooth. In fact, a garden snail can find itself in a somewhat thorny situation. But a snail's foot is very flexible and very tough. It can move the animal safely over sharp or pointed surfaces. Now, if we're defining a foot as a part of a living thing that moves it along, then a snake has a foot. But a snake's foot is quite different from a snail's foot. It's built into this vertebrate's belly, running the whole length of its body. You can't see the foot because it's hidden under the snake's scales. In vertebrates, muscles move bones, and a snake's foot is a layer of muscles attached to the snake's ribs. Those muscles ripple in waves like the foot of a snail, moving the ribs in the same rhythmic way. The ribs, attached to a snake's spinal bones, work like rows of oars, pushing against the ground, moving the snake forward in a smooth motion. The snake almost seems to swim across the ground, propelled by the rippling of its long, hidden foot. Here's a creature with 2 feet, but no legs. It's a common leech, the kind that sometimes bothers outdoor swimmers. The leech has feet at both ends of its body. Like a suction cup, each foot grips whatever surface the leech is clinging to. Front and rear feet take hold alternately while the leech bends and straightens its body. A leech moves very much like a looper does. This is sometimes called an inchworm, but it's actually the caterpillar of the geometrid moth. It has several feet at each end, but because the caterpillar works its muscles like the leech does, it moves in a similar way. Here's another caterpillar, but this one has an abundance of feet. It's a puss moth caterpillar. Although this creature has many feet, its movement is surprisingly similar to the movement of other animals we've seen. Contraction waves lengthen and shorten its body, but the real propulsion comes from 3 front pairs of feet on the thorax and 4 rear pairs of feet on the abdomen. The pointy feet in front work as a team, pulling the insect's body forward. As the front feet pull, the rear feet push. Teams of legs, shifting jelly-like substances, changing body shape, paddling cilia, rippling muscles. These are only a few of the remarkable ways that living things move.